Welcome to Across the Globe. Today we will learn about hyperparameter tuning basics. Hyperparameter tuning involves optimizing predefined settings, known as hyperparameters, to enhance a machine learning model's performance. These hyperparameters influence how the model learns and makes predictions. By adjusting these hyperparameters, such as learning rate or regularization strength, the model's accuracy and effectiveness can be improved. For example, in a neural network, tuning the number of hidden layers or batch size can result in better classification accuracy. Without proper hyperparameter tuning, a model may underperform or overfit the training data, reducing its generalizability to new data. Hyperparameter tuning is a crucial process in machine learning, as it can greatly enhance a model's performance. By finding the optimal values for hyperparameters, such as learning rate, batch size, or regularization strength, the risk of overfitting or underfitting the model can be mitigated. This optimization not only enhances the accuracy and robustness of the model, but also saves time and computational resources by reducing the need for manual trial and error. For instance, when training a neural network for image recognition, adjusting the learning rate and batch size through hyperparameter tuning can help achieve better classification results while avoiding overfitting the model to the training data. To optimize model performance, one can employ tools such as GridSearchCV or RandomizedSearchCV from the scikit-learn library. These tools systematically explore a defined parameter grid or distribution to search for the best hyperparameters for a given model. By fitting the model with various hyperparameter combinations and evaluating performance metrics, one can identify the set of hyperparameters that yield the best results. For instance, in a scenario where one is training a random forest classifier, GridSearchCV can be utilized to search for the optimal number of trees and maximum depth by defining a parameter grid with corresponding values. The tool then runs the model with different combinations, assesses performance through cross-validation, and selects the hyperparameters that achieve the highest accuracy or other specified metric. To optimize a random forest classifier model, GridSearchCV from scikit-learn is used. In this example, we vary n estimators and max depth parameters within specified ranges to find the best combination for the model. A random forest classifier is initialized. GridSearchCV is configured with the parameter grid and cross-validation value CV equals 3, and then the model is fitted to the training data. After training, the best parameters are obtained using gridsearch.bestparams. This approach helps to tune hyperparameters efficiently, leading to a better performing model. Just like we fine-tune the settings of a car to achieve optimal performance, hyperparameter tuning is the process of adjusting the settings of a machine learning algorithm to maximize its accuracy. Hyperparameters act as the knobs and switches that we can turn to fine-tune the behavior of the algorithm, similar to how adjusting the car's suspension or fuel mixture can improve its performance. By systematically testing different combinations of hyperparameters, we can find the optimal configuration that results in the best model performance, just like test driving different settings on a car to see which one gives the smoothest ride. Once we have determined the best hyperparameters through experimentation, we can plug them into our machine learning algorithm code to ensure it runs at its peak efficiency, similar to setting the car's configuration for maximum power and fuel efficiency. Hey code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The provided Python code showcases the implementation of hyperparameter tuning using GridSearchCV from scikit-learn on the famous Iris dataset. Firstly, the necessary libraries are imported, including modules for loading the dataset, model selection, and the random forest classifier ensemble model. The dataset is then loaded and split into training and testing sets using the train-test-split function. A random forest classifier model is defined for classification tasks. A parameter grid param grid is set up with potential values for hyperparameters such as the number of estimators, max depth, and minimum samples split. The GridSearchCV method is employed to systematically test various combinations of hyperparameters using cross-validation with 5 folds. The best hyperparameters are identified using the best params attribute of the GridSearch object and printed to the console. The model is then evaluated using the best hyperparameters obtained from the GridSearchCV. The accuracy of the model on the test data is calculated and displayed to assess its performance. This code example illustrates the process of fine-tuning hyperparameters to enhance the model's performance. It aligns with real-world scenarios where tuning hyperparameters optimizes the model's behavior, similar to adjusting a vehicle's settings for peak efficiency. Hyperparameter tuning using techniques like GridSearchCV is vital across various industries. For instance, in the financial sector, optimizing hyperparameters of machine learning models can enhance the accuracy of stock price prediction models. By tuning hyperparameters such as the number of estimators, max depth, and min samples, split in a random forest model, financial analysts can improve the accuracy of predicting stock movements. This optimization can potentially lead to better investment decisions and increased profitability for investors. Similarly, in the healthcare industry, hyperparameter tuning can play a crucial role in enhancing the performance of medical diagnostic models. By effectively tuning hyperparameters, such as those related to the depth of decision trees or the number of neighbors in a k-nearest neighbors model, healthcare professionals can build more accurate predictive models for diseases like cancer or diabetes. This, in turn, can assist doctors in making more informed treatment decisions and potentially saving lives. Therefore, understanding and implementing hyperparameter tuning techniques are essential for improving the performance and reliability of machine learning models in various real-world applications across the globe. Keep learning, stay curious, and I'll catch you in the next video.